Okay, let's get started on the vector unit. So in lesson 1, we are going to start with geometric vectors. So within the vector units, we will look at geometric vectors and algebraic vectors. So a vector could be looked at in 2 dimensions, or it could be looked at in 3 dimensions. So we will do both. The 3-dimensional vectors will be in the later units, but for the initial units we'll look at vectors in 2 dimensionals, and we are going to look at it algebraically and geometrically. So before we get started with the vectors, we have to do a bit of review of trigonometry. So we did start trigonometry in grade 10, and we looked at law of sines, law of cosines, and we also looked at right angle trig. So let's write this out here. So we have our right angle trigonometry ratios, sine, cosine, and tan. So think of a right angle as having 3 sides, the hypotenuse always being across from the right angle, and then the other 2 sides will be reflected in which angle we are working with. So if this angle theta, then the side that is next to it or attached to it is the adjacent side, and the side opposite or not attached to it is the opposite side. So we have 3 right angle trig ratios. Because we have 3 sides, we can compare 2 at a time. So if we compare the opposite side in comparison or ratio to the hypotenuse, we call that sine. If we compare the length of the adjacent side to the hypotenuse, we call that cosine. And if we compare the length of the opposite side to the adjacent side, we call that tan. So these we can use with right angle trig or triangles only. If we don't have a right angle, we have to move on to law of sines. If we are going to use law of sines, we must have a complete ratio. So a complete ratio being a side and the angle opposite the side or across from the side. So it is important when we are using law of sines and law of cosines that we label our triangles using capital letters for the vertices, and then the opposite side would be the same letter but in lowercase. So our opposite angle A is side A, opposite angle B is side B, and opposite angle C is side C. So the law of sine says that the ratio of a side and the sine of its angle opposite that side is always in the same ratio. So A over sine A equals B over sine B equals C over sine C. And you can do it the other way if you prefer, putting sine A over A, sine B over B, sine C over sine C. The law of cosines is also with a non-right angle triangle. And we use that when we have a, let's just circle this, we use that when we have a contained angle. So law of cosines would occur if we had a contained angle. What is a contained angle? A contained angle is an angle in between 2 sides. So the reason we have to use law of cosines with this triangle is because we don't have a complete ratio. So a complete ratio being an angle and the side opposite. So if we look at, let's call this ABC. In this red triangle, we have angle A, but we don't have side A. We have side B, but we don't have angle B. And we have side C, but we don't have angle C. So we would have to use cosine law because we don't have a complete ratio, and therefore we couldn't use sine law. And also, if we had all 3 sides, let's again call this A, B, C. So let's call this 6, 8, and 12. If we had all 3 sides, we would have to use cosine law as well. So those are the 2 cases where we would use cosine law, if we had a contained angle or we had all 3 sides. Okay, so let's look at a couple of questions. So in the first question here, it says a right angle triangle has a hypotenuse of length 12, one angle of 57. Use sine and cosine to find the lengths of the two remaining sides. And check your answer using Pythagorean Theorem. So let's just draw a diagram and put on the information that is given. It says we have a right angle triangle. The hypotenuse is 12 centimeters. And one of the angles is 57. So it doesn't really matter which angle. We want to find the two remaining sides. So I'm going to call this ABC. So if I want side C here, well, let's use just X and Y, because we don't really need to call it A and B if we are using just right angle trig. So let's call this side X and this side Y. So let's say we're looking for side X. So X is adjacent to the 57, and we have the hypotenuse. So if we look at our three trig ratios, we would use cosine, because cosine is the adjacent side over the hypotenuse. We know the angle is 57, the adjacent is X, and the hypotenuse is 12. So in order to solve for X, we could just cross multiply. So we'll do 1 times X, and we'll do 12 times cosine 57. Just make sure when we're using trig that we are making sure our calculator is in degree mode. So I'll do 12 times cosine 57, and I get 6.5 centimeters. If I wanted to find the value of Y, Y is opposite the 57 degrees, so I will use sine, not cosine. Opposite over hypotenuse. So again, the angle is 57, the opposite side is Y, and the hypotenuse is 12. So in this case, if I want to find Y, again, we will cross multiply. So I'll just put this over 1. And cross multiply, so Y would have a value of 12 times sine 57. We'll just type that into the calculator, and we get a value of 10.1. So it's just normal right angle trig, finding the value of sine and cosine, and then we're just going to check our answer using Pythagorean Theorem, because it is a right angle triangle. So it should be able to have the left side equal the right side if I put in these values. So I would have 6.5 squared plus 10.1 squared should equal 12 squared. And we'll just calculate that. 6.5 squared plus 10.1 squared has a value of 144.26, and we would have to square root, and that works out to be approximately 12 and a little bit. Let's see, 12. So it's not always an exact, and the reason being because we rounded. When we found X and Y, we rounded our values, so we won't have an exact value, but we'll be pretty close. So it's 12.01. So it does check with the Pythagorean theorem. So that's just basic right angle trig. If we have a missing side, we're going to use a squared equals b squared plus c squared minus 2bc, and then we're missing something there, cosine a. So there is a pattern. So whatever side I want, it will be the other two sides squared, added together, minus 2 times the other two sides, and then cosine of that same angle. We're going to use this version to find the missing angle. We've got the two sides squared minus the initial side divided by 2bc. So, and these questions are from the guide. These are just some practice questions. So in question 2, we have triangle XYZ. It is a right angle. It says that X is 90 degrees, so let's put that in here. Y and Z, so side Y is 14, and side Z is 20. And in this question, it wants us to find x and y the angles. So let's do y first. So if we're looking for angle y, we have side 14, which is opposite, and we have side 20, which is adjacent. So we could use tan of angle y is the opposite over the adjacent. So the opposite is 14, the adjacent is 20. If we want to find the measure of an angle, we want to use the inverse function of tan. And you will see tan with the little -1 there. So the inverse of tan. And we usually round to the nearest whole degree. So angle y will be approximately equal to 35. Again, making sure that our calculator is in the degree mode. If I want to find angle z, again, we have opposite and adjacent. They're just in a different order. So tan of z, we'll use the opposite side over the adjacent side. In this case, opposite would be the 20, and the adjacent would be the 14. And we will use our inverse tan to solve for angle z, and that works out to be 55. And then it just wants to make sure that all our angles add up to 90 or 180. So 90 plus 35 plus 55 do indeed add up to 180 degrees. Okay, in question 3 and 4, I think our cosine law. Go back to this question. Triangle XYZ. Angle y is given as 36, xy is 8, side yz is 11, and we want to find the length of the unknown side. So we are missing side y. So I'm going to use sine law. I have a contained angle. I have an angle in between two sides, so I need to use cosine law because I don't have a complete ratio to use sine law. So we're going to use cosine law. We're looking for side y. So it will be the other two sides squared. So x and z squared minus 2 times the other two sides, and then cosine of angle y. So we'll fill in side x is 11, side z is 8. And angle y is 36. Just keep in mind when you're doing these calculations that I'll do a little bit of extra steps here. So 11 squared is 121, 8 squared is 64. Make sure when you do these calculations that you're calculating all of this as one number. Don't do 2 times 11 times 8. Do your addition, subtraction, and then do cosine 36 at the end. Remember, order of operations says I have to do all this multiplication first before I add and subtract. So I have to do 2 times 11 times 8 times cosine 36 as one value. It works out to be 142.387. Then I could do my addition and subtraction. So I'm going to do 121 plus 64 minus 142.387, and it works out to be 42.613, and then we will square root to find the value of y. So that's just a little calculation reminder that you want to follow order of operations and make sure you do all that multiplication before you start to add and subtract. To the beginning. The other version, do 4 first. In triangle DEF, we have angle E is 49. We have angle F is 72. And we have side D is 57. And we want to find the length of side E using the sine law. So I'm doing this first just because it's sine law. Okay, so in order to use sine law, you have to have a complete ratio. So I see that I have angle E and I'm looking for side E. So I will use E over sine E. I have side D and I have angle F. So I don't have a complete ratio there, but I could determine side angle D by using the fact that the three angles add up to 180. So if I subtract 72 and 49 from 180, I will be able to determine angle D. So let's do that calculation. So we've got 180 minus 72 and minus 49, and that works out to be 59 degrees. So I could figure that out, and so I do have a complete ratio here. I have side D and angle D. So I'm going to use D over side D. So let's fill in the information that we know. So we don't know side E. We know angle E is 49. We know side D is 57, and we know angle D is 59. So we're going to cross multiply. So we're going to multiply these two together and these two together. So we would get E sine 59 equals 57 sine 49. And if I want to isolate for E, I would divide by sine 59 and do the same on the other side. Okay, so in order to get angle or side E, I have to multiply 57 times sine 49 and then divide by sine 59. And that works out to be 50.2 meters. So make sure that you include the units if they are given. Then it says verify using the cosine law. So I could use the cosine law looking for side E. So when you use the cosine law, let's just go back. So if I'm looking for side E, I would do E squared. It would be the other two sides squared, so that would be D and F, minus 2 times D and F, and then cosine of the angle of that same letter, so cosine E. So let's fill in. D is 57. F is, oh, we don't have side F yet. So let's go back and find side F because we need that information. Probably should say that in the instructions. So we need F to do cosine law, so let's do F. So we'll do F over sine F, and let's use D over sine D. So F we are looking for, angle F is 72. Side D is 57, and angle D is 59. And again, we'll cross multiply. 57 times sine 72 divided by sine 59, and side F works out to be 63.2. Okay, so let's go back to our cosine law, which we are doing to double check that we get the same answer. So side F is 63.2, which is squared. 2 times 57 times 63.2, and then cosine of angle E is 49. Okay, and if we do all these calculations, E works out to be, let's type it all in, 50.2. So it does indeed give us the same answer whether we use sine law or cosine law. So generally, we try to use sine law first. We don't have to. You do have options, and we're going to do an example where we will see that sometimes it's better to use cosine law than sine law when we have the option of using both. Okay, so in question 3 we used cosine law. In question 4 we looked at using both, and we saw that we got the same answer. So in question 5, if we have the option of using sine law or cosine law, sometimes it's better to use cosine law, and I'll show you why. So in triangle ABC, let's move this up a bit. So we have triangle ABC. And we are given side BC is 10, and AB is 8, and AC is 15.5. And angle C is 27. So we do have the option. It says use sine law to find angle B. Then it says use cosine law to find angle B. And then we're going to compare the answers. Okay? And we want to see if we get the same answer or not. Okay, so I'm going to use sine law to find angle B. So here's angle B. So I'm going to use B over sine B. And then the complete ratio I have given is this one, C. I have the side C and the angle C, so I'm going to use C over sine C. So B is 15.5. Angle B we don't know. C is 8 and angle C is 27. So we'll do sine B, cross multiply, would be 15.5 times sine 27, and then it will be divided by 8. Now remember that we want to find the angles, so we'll have to use the inverse function at the end. So I'm just going to do this calculation, 15.5 times sine 27, and then divide that by 8, and we get decimal 0.8796, and then we'll do the inverse sine of that to find the angle. So it works out to be approximately 62 degrees. Okay, then it wants me to use cosine law to find angle B. So if I'm looking for angle B using the cosine law, I would use cosine B, and we're going to use, let's go up cosine law. So if it's cosine B, it would be a squared plus c squared minus b squared over 2ac. So a is 10, c is 8, and side B is 15.5. And then we're going to do inverse, right, because we want angle B. So we've got 10 squared plus 8 squared minus 15.5 squared equals negative 76.25. 2 times 10 times 8 is 160. And we'll do the inverse of that to find angle B. And it works out to be rounded 118. So the question is, why did we get two different answers? We got 62 when we use sine law, but we got 118 when we use cosine law. So if you think back to our quadrant trig, 62 degrees would be in quadrant 1, right? We measure from 0 in the counterclockwise direction. And 118, so if you think of 180 minus 62, you'll see that you get 118. And that's because they have the same related angle. So 118 would go to quadrant 2 and would have a related angle of 62. So if you remember your cast rule, all the ratios are positive in quadrant 1, but only sine is positive in quadrant 2. So sine has a positive value in quadrant 1 and 2, whereas cosine has a positive value in quadrant 1, but a negative value in quadrant 2. So when you do these calculations on your calculator does not know that. It does not understand that cosine is negative in quadrant 2, even though the angle is the same. So if you typed into your calculator, so you'll see that the sine ratio is 0.08796. So if we did sine 62, just to verify, if I type in sine 62, I get 0.88. And if I do, I'm just rounding that, if I do sine 118, I get 0.88. So I get the same ratio. That's because the related angle is the same in quadrant 1 and 2. And sine is positive in both quadrant 1 and 2. If I did cosine 62, let's type that in, I get 0.47 rounded. If I did cosine of 118, I get negative 0.47. So when you're doing these calculations, to get around making sure that you get the proper angle, the correct angle, it is better to use cosine law than sine law, because when you use cosine law, you will get the correct angle based on the sine, so whether it's positive or negative. When you use sine law, you might end up with the wrong angle. So you might think it's 62 when actually it's a supplementary 118, because your calculator doesn't know the difference in those angles because the ratio is positive in both cases. When you use cosine law, your calculator knows the difference in those angles because one will be positive and one will be negative. So your conclusion is that if you had an option, it is better to use cosine law than sine law. So that is a bit of a review of our trig functions. We need these trig equations to solve vector questions and applications. So that is just a quick review. You have looked at this in grade 10 and 11, so it should not be anything new, but it is good to just go through some of those questions and practice, making sure that you know how to use sine, cosine, tan, right angle trig, know how to use sine law, and know how to use cosine law.